Okay, we can get started now. Welcome everyone to the Field Crops Virtual Breakfast. My name is Korede Olubinle. I'm a field crops educator based in Lenawee County, covering the southeast portion of Michigan. So I would like to introduce Rich Price. He is our conservation systems agronomist educator with Extension, and today he will be discussing using yield data effectively. Okay, you can take it away, Rich.
Thank you, Corday. Title of my presentation and the focus of the work that I do with Michigan State Extension in coordination with Bruno Basso's lab on main campus involves precision agriculture. And mainly what we talk about in precision agriculture is more of a modern take on what we see now in equipment going through the field. So the first slide that I want to reiterate on is I grew up on a farm in like central mid Michigan, and one of the first tractors that I learned how to drive on was this one up here on the left. And the only real display that was useful for what you were doing is once you put it in gear and you decided what you're doing was that center console and the tachometer. So we wanted to see how many RPMs we got to get our PTO spinning at that point. Well, fast forward to today, the farmer on the right on his screen that he's seeing still has the tachometer, which is part of the machine itself. You can see in the bottom of that photo. But at the same time, we've got multiple screens feeding us information and feeding us data for all the different things these technology can do. So, between 60 years ago and today, the whole idea is that these technology and coupled with high intensive data analytics, which a lot of ag tech companies are offering now, can give us more refined measurements and put things exactly where we need them. This is really common in with larger farms and what we call digital tools. So right now, some of the leading platforms that are available out there are from John Deere with Operations Center. Climate has a program called FieldView, and Ag Leader and Agfinity are some of the more common tools that any grower, any farmer can sign up for, and they integrate with their machinery that they have. Now, I like to describe things in my own world and say that my computer that I have is an Apple computer. The cell phone that I have is an Apple cell phone, and the headphones that I have right now that I'm using to give this presentation are Apple made headphones. So because I'm in the Apple universe, all of these technologies and different tools work seamlessly together. The same thing is true for the ag tech platforms. If you're using something like by John Deere or Climate, it's more advantageous to have like be live in the climate universe, whatever kind of equipment you have. With John Deere, it works really well if you have the green machines going too. And what does that data tell us? And so this is the screenshot from Operations Center for a grower that has shared their data with me. And this is just a visualization of the map. So when we talk about these data that we collect, and more specifically the yield data that we're getting from these machines, what we're doing is we're visualizing the productivity at a much smaller scale, fine resolution, we'll call it. Instead of saying, yeah, my average yield for say corn or soybeans, like corn is 200 bushel, soybean is say 80 bushel. Instead of saying that average, which sometimes can encompass the whole field, now we can say, well, we see parts of your field that maybe that corn, maybe it's 220 bushel, or maybe in the low spots, maybe it's 120 bushel. And all of that would average out, but now we can see the field with much higher resolution. So the question is what do we do with that data to inform us of the future? And so what the falls short from the tech companies is the idea that you can combine these maps and you can have an understanding of how these zones vary over time. And so the sad part about this is that I have access to all those different systems. And because they all are owned by a different company and they do things differently, the idea of combining them into one kind of zone can vary. In the Basso lab at Michigan State, what we provide from that data is what we call a stability map. And so the stability map really does emphasize those zones that are doing really well. And in this map on the right, it's those blue zones, those are my high zones. And then in the red zones at the bottom, those are the spots of the field that are not doing well. Again, climate and John Deere and Agfinity through SMS offers something similar in a long-term analysis, but it's doesn't consider crop agnosticism, which means that the crop is the values are unique and taken in context with like one composite map. But good news, the a platform which Bruno is working on as part of a grant, we hope to have available soon where this could be open to all farmers. So this one's kind of intense, but this is a figure showing how those yields respond with no management input over time. So we think about, what Jeff is about to talk about pretty soon is, hey, we finally got some rain in mid-Michigan. Does that help? Well, for the past 2 months, we've been pretty dry. And in those areas that are high, we would expect that even if it's pretty dry, those areas would be higher than the rest of the field because they've always been high. And so, why are they high? Well, they have probably better water holding capacity from the soil. They probably aren't at the edge of the field where they're affected by shading and deer damage and other sort of animals, and they're generally the higher producing. So when it comes to things like drought, these areas are more resilient. And this graph shows that regardless of the year, so I've got 2023 all the way through 2007, my blue zones were always highest in the field for yield. And this is of like 500 fields throughout Michigan, Indiana, and Ohio. And so the main concept of this, and this is not a new concept, is the idea that we can manage these zones effectively to give us site-specific recommendations for how many seeds we plant, how much fertility we give. Obviously, we can't control what Mother Nature gives us in temperature, solar radiation, and rainfall. But the things we actually can control with precision agriculture, now you can dictate exactly how many seeds or how much nutrient you want at a very fine scale. But like I said, it's not a new concept. The idea of farming these zones has been around. And the first thing we thought of was, well, Sturgo came out and dug some holes around the entire state. In fact, the actual all 48 states, we can have a Sturgo map that gives us an idea of the different classifications that we have in our field. That's one way to do it. It's very common too to go out and poke some holes on a 2.5 acre grid and collect soil samples. So I go out and I poke my hole in the fall. I get my P measurement. I send it to the lab. I get my P, my K, my nutrient analysis, and then I get a binder back with all those maps. The other idea is we can look at topography and elevation. How do those zones compare to what we're seeing in the field? And then the last one, which is a more recent advancement, and it's something that I've done in the lab with Bruno, is using remote sensing. So whether drones and now satellites are really common, where on a clear day, any field in the state of Michigan, we can have an NDVI image of the field with really high resolution. But to emphasize why the lab focuses on yield and the idea of stability is that what are we getting out of the field? What is the outcome of the work that we have in this? At the end of the day, it's really about the yield because the yield is what drives our profit. And when I have these maps and I work with a farmer who wants to have these developed for them for their farm, and the first step that we do is we get the data and we show them. The farmer tells me exactly each field. Oh yeah, I know that's a bad spot. Oh yeah, I know that's a good spot. Why? Because they've been farming it for, you know, tens, 20s years, and they're used to seeing those spots as they go through the field. So to get further to that point, if any farmer that's on this call or that wants to have this step done, like I said, right now it's not commercially available. Some of the apps do a really good job of cataloging the data and keeping track of it as more of a virtual or as a digital record book, but the stability analysis itself does not exist from any commercial capability. But if any farmer wants to have this done, it's pretty easy to share the data. I can get it, and then the lab can process it. And this is the first step of what that looks like. So on the left, I have a farmer who shared some data. This is not in Michigan. I'm not giving anything away. But the first step we do is we map out where all the fields are. And then on the right, those stability maps are created from all of the yield data that they give us. And it's a minimum about 3 years to make this stability analysis. Um, like we would like to have more because more data is a better thing in this work. But two data is usually just a straight line. Three data points, we kind of get a curve and we see how the field responds to different variations, which are mainly in temporal. So all the fields are mapped. You can see on the right how all these fields have this, this green, this blue, this red. And this is exactly what makes farming a very, very difficult thing, is that the variations that we see, the different zones that we see, no one field is alike. It's almost like a fingerprint, right? Every field has its unique fingerprint for all these different reasons that I don't want to get into. But now I'm saying is that the yield data we have can give us an understanding of how to better manage things in each zone. So once we have our maps, and this is something that the lab has done in the past 4 or 5 years, was to really take that map and say, okay, what actionable result are we able to get out of that analysis? And so here you have a picture of a farmer going through and side dressing his corn. And my question I always pose when we're talking about doing some variable rate is if we saw this part in the field where I don't have any plants. Now, I'm sure a lot of the farmers can guess why I don't have any plants in this field. But if we're relying on, say, remote sensing, say NDVI or any one of those fancy indices, and we're going to give a prescription of fertilizer, the prescription would say that if so a lot of prescriptions say in low fertility zones, well, what do the plants need to get back to being healthy? Well, they need more fertilizer, right? In a situation like this, does more fertilizer help? So understanding how we use those maps and then taking it to the field, it's still a difficult component. We can't just have one flight. We can't just have one map and say, this is what we need to do. We need to integrate other technologies to really figure out what the rate is going to be. The stability analysis we have tells us where our historical yields have been in the past and where we're likely to find good yields in the future, but they don't tell us the rates. They don't tell us what we need to put on exactly, because that is more of a question of Mother Nature. So at the beginning of 2025, we had no idea what was going to happen for the rest of the summer. Those maps would indicate, well, given all those years, these are the good spots. And so this zone would either show up probably in a low or probably in another zone that we call unstable, because water dictates how those zones can change either really high or really low over time. And so a lot of farmers see those zones pretty commonly in their fields. So for the prescription data that I'm going to present on, we'll be first focusing on variable rate. So this is my variable rate map that I have. I sent this to a farmer, and like I said, in the low zones, I expect them to put low fertility, and in the high zones, we expect them to put high fertility. And then in my map on the right, I have these little blue and yellow green checkerboards. Those are what we have in place of a check strip. We put check boxes because we control exactly where the rate goes in that spot. And that gives us enough of an area to pick out specifically from the yield data whether or not we had an effect from our fertilizer. We take it to the field, and my map on the right, which is probably covered up by our photos, shows that there's actually a difference in what the target rate applies versus the as applied. So in precision work, one of the more common um, terms that gets thrown out with these monitors that are putting the fertilizer on is what's called an as applied map. So the target rate is just exactly what the machine is trying to get to, but the applied rate can vary from that. So it's important from our standpoint, from a research standpoint, to actually get the as applied, because now we can say for certain what was actually put on for the field when the applicator went through. And what does it look like? So at the end of the year, it's really important for us to go through and do a complete analysis. So this is from data from 2024. The wheat data that we have from 2025 just came in and we're analyzing it now. But we had 2,000 acres of VRN wheat applied in 2024. And those rates from all the farmers that we work with varied by what the farmer standard was. So we had to categorize them and say, okay, the low rate was anywhere, and this is total unapplied, was anywhere between 60 and 110. The medium rate, anywhere between 90 and 130, and the high rate, anywhere from 104 to 150. And then what we tested was what was the yield in those stability zones based on the rate that we applied. And there's a slight uptick in the curve. So in those low zones, even if you applied the high rate, you still got low yield. And conversely, in the high zones, with the low rate, you actually got a higher yield, higher nitrogen use efficiency because those zones were typically more from the high yielding zones. So what does this mean? So we took each farmer's business as usual rate, which is the standard rate they would apply in a uniform situation, and we determined from the prescriptions that we sent how much nitrogen was saved. So in our low and stable zones, the farmers that we showed that, hey, these are always bad low zones, you shouldn't be applying a ton of fertilizer because you don't get the response. So when our prescriptions were sent out, we saved farmers nitrogen, which can be directly correlated with money. And it varied for each farmer, right? That's why the box plots are kind of all over the place, but they're all above the zero line. In the medium and stable, we dialed it back a little bit and still got some good response. But in the high and stable zones is where we actually saw a negative savings. So negative savings means we turned around and the nitrogen that we didn't put on those low zones, we in turn put more into those high zones because that's the spot where we could push the yields, push the nitrogen, get higher yields, and have a higher return on investment. So my last few slides are going to focus on, okay, great. You showed us how we do this. You show us what the benefit could be. So now what we're focusing on is turning this prescription at the end into a profit map. So my map on the left is the variable rate. This is the spatial pattern. We said this is what's going to match this. And then on the right is that actual yield map was turned into profit. So in those green areas, the farmer made money according to the scale that I have. In those red areas, the farmer lost money. There's negative dollars being made in those zones. And you can see that even though it's not exactly the same, there is some spatial patterns that we can recognize, right? So some of my spots where it's red on the right on the map, those were my low zones that I had in the variable rate map. And we actually put more fertilizer in some of those zones in order to figure out, where those low spots yielded. So the final two slides that I have is saying, well, what if I have a spot in this field that is constantly low, and then through the economic impact, it's constantly losing money? Okay, well, why are we still farming it? And I've had this conversation with farmers, and we've had little traction on it, but it's starting to pick up more now that input costs are not coming down, land prices are high, and commodity prices are what they are. The idea of not farming land was unheard of 20, 30 years ago. But now with these data, we can actually say, well, you shouldn't not farm the whole field. There are parts of the field where you shouldn't farm and parts of the field where you should farm. So for this particular field, it's basically the field border. And what do we think affects all of those areas at the northern part of this field, the top part of this field? Why are those the low zones in the yellow? Well, they're probably being eaten a ton by deer. That's probably a big reason why those spots are low. So the field on the right, the farmer went through and removed those zones from production. And my last slide shows my contact information if a farmer wants to get a hold of me. And it shows the northern part of that field that he removed from production and planted with native species. So that's what I have for today. I'm going to stop sharing.
Yeah, thank you, Rich and Jeff, for the presentations. Very informative. So yeah, if you have a question, you can add that to the chat. We already have a few questions. The first one by Clay, I think Rich already answered, was the cost to get layered maps, and Rich mentioned that it costs $0 from MSU. You can contact Rich. He put his email in the chat as well. Clay also mentioned what is the impact on soil in the high fertility soils with added fertilizer.
So that's a good question. I think um, what we add in fertilizer, additional fertilizer than what was already there in, say, a normal uniform application rate, doesn't change fertility much more because, especially when it comes to nitrogen, the whole goal is to try to meet the plant's demand. So in those high zones, say in corn, for example, you're feeding the plant, say, trying to get 200, so 1 bushel per 1 unit of N that's applied. If we give it more, the data shows that it'll grow more and it'll utilize that. So there's not a lot of ton of leftover. The idea that I didn't touch on from an environmental standpoint is try to reduce losses, right? So if we put 200 pounds of nitrogen on a spot that only yields 100, you're wasting 100 pounds, so that has a cost to it, and 100 pounds is lost to the environment, which has another cost, which it's harder to actually monetize to a farmer standpoint, but we can definitely do that from an environmental standpoint. So that's why the prescription is really trying to just tailor exactly what the plant needs, as we go through the field.
Nice. The next question, I think it may be for Jeff, was does the map or chart also address the corn's moisture as well as the maturity black layer?
Oh,
That might have been for Jeff.
Yeah.
I think it actually might be for for Bert Craig if he were here on for most season. This is out of my area of expertise, actually. But typically, we're looking for late fall when we don't expect any regrowth to occur until next year. And I know for many of those perennials, like a maple tree, it's you can still plant them next spring, but it's preferable to go the fall before and give the plant some chance to acclimate a little bit, even though it is the cold season. But that typically would be coming up later. And then he would be the one though to at least in terms of the timing. But I think most of that goes on here at the end of the fall, maybe even into almost into early winter, but certainly later than we are right now in this transitional season.
Steve asked the question, what is an easy first step for growers to begin utilizing this technology to make management decisions currently and the current limitations of the technology as well?
So I think it's best to start with the limitations on it, that the technology that's very commonplace tends to be with bigger farmers. If you spend $100,000 on a brand new tractor, it better come with auto steer. It better come with the monitor that attaches to your, very expensive planter, or your very expensive combine should have that monitor. So the limitations are this stuff is basically already ready to go out of the box for farmers with newer equipment with bigger farms, and then it just snowballs, right? Because they have that technology, it comes with the software package, which I mentioned before, like John Deere Climate or Agfinity, which helps you kind of keep those maps and keep things organized in catalogs. So if you're going to just get into this and you're a hobby farmer and you have no yield data, you're not left in the dark. Like I said, it's not what Basso's lab does specifically is not commercially available, but right now there's a grant that he has that's working on a project which will make this available to every farm in Michigan, because we're going to use historical satellite imagery to generate these maps. So a farmer doesn't have yield data, but I still want to do variable rate on my field. I still want to see where my zones are in my field. We can do that from satellite, but it's not available yet. It's year one of a 3-year project. So by the end, if I do this virtual breakfast in the next 3 years, I hope I can program and coordinate and show you how that works. But like I said, so the easy first step. So if you do have that technology you're doing, it's really just keeping the maps and the data consistent. Some of the farmers that I get data from, I have the same field and it has 3 different names because it depended on who was in the machine at the time and what they had historically called that field. One year it was Dad's farm. One year, because it was the guy's cousin, it was Uncle Bill's farm. And even though that was the same field, they called it something different. So even if you want to have that data analyzed through your commercial application, it's good to keep the same naming convention as we go through.
Yeah,
Sounds good.
awesome answer, Rich. I just wanted to caveat onto that because, you and I have worked on like the potato field day, trying to address this similar problem set. And just to like enumerate that a little bit, like this layering and mapping gives you sort of a snapshot of what's going on, but not yet a prescriptive answer. So if you've got an agronomist deployed on your farm, or you work with, say, like a an ag service agency that provides some sort of like custom rate application, there's still an element of the farmer's footsteps that needs to be a part of that prescriptive answer. Is there not? And
Yeah,
that's kind of where we're at.
100%. I mean, the goal is to produce a crop that we can sell more than what it costs us to grow that crop. That's essentially what making a profit. We don't making a profit. And if we don't make a profit, we can't continue to stay in business. And yet, even though that's the goal, most farms are doing it differently. To come back to nitrogen management, some farmers put everything on up front and just let the season happen. Some spoon feed it a little bit, as we're going along in the beginning, and then come back and side dress once. Some farmers side dress twice. In potatoes, you're putting nitrogen on multiple times throughout the season, and a lot of times it's aerial applied. So even though the goal is to get, to pay for that crop and to get it to where we're making more than break even, the way we go about it can change. And then, like I showed the map with all those stability maps from the farmer that I had on one of those slides, all of those fields are also unique too. So it's the best thing is to say that each field is a fingerprint, right? It's super unique.
Thanks,
Mm,
Rich.
yeah. Okay. I'm gonna like combine two questions. So can you generate maps for farms in Arizona? And does MSU agree not to disclose the data provided?
Yes, so the if any farmer shares yield data with me personally through my email that I shared, it goes to Bruno's lab, and Bruno's lab is located on main campus. The servers where the data stay are only accessible by people within Bruno's group. And so by sharing the data, it doesn't go to any company, it doesn't go any outside, it's just used within the group for research purposes. As you saw in my maps that I showed, no farmer's name are ever disclosed in a publication or a presentation that we have. All of that is kept, lock and key in house. For farmers outside of the state, of course, yield data can come in. It's the same as if it were in Michigan. If the farmer doesn't have yield data, we actually can still get that the idea of stability from historical satellites. And historical satellites, I mean, Landsat has been going through around the Earth for 20 years, Sentinel for 20 years. So there's multiple satellites that we can pull the data from. And I think the part that's really disheartening is it's really hard to do. So I can't say that I can teach every single farmer out there how to get satellite on their satellite data for their farm. Farmers are already inundated with so many things that keeping them so many busy is that if you wanted to integrate satellite stuff on your own farm, you have to allocate another few hours a day to learn how to do programming and to get that data. So don't do that. Come to me and I will do that as a service of Michigan State University Extension.
Yeah. Um, I guess that kind of answers the next question of where do you get satellite images from? You can just contact Rich. Um, Also, does using planets imagery allow you to get more precise charts slash maps?
Yeah, so that's a good point. Is Sentinel is the European satellite that's publicly available. It's free for anybody in the world with an email address to go and log in and download that data. But like I said, it's really difficult then to go ahead and process and see what that actually means. Landsat is available as well, publicly free. Planet Data is a company, Planet Labs is a company in San Diego, a private company. They send up satellites, and that data is not free. You can sign up for an educational license, which a lot of Michigan State extension people have, and you can get only a few thousand acres each month that you can download. But if you want to buy, get a lot of stuff, you have to pay for it. But the benefit to Planet Lab satellite imagery is it's every day. Planet has a satellite taking a picture of your field every single day. And it just rained yesterday, so the picture they got doesn't do us any good. But the day before that was a beautiful, clear, sunny day. We can get that imagery.
Nice. Clay, do you have a question?
Yes, Dr. Andreas, my question was, does that map that showed the black layering with the different temperatures, does it address corn moisture?
Hmm. Uh, not directly. That a good question. It's purely looking at thermal accumulation, the degree day accumulation, and whatever that particular hybrid is on book on paper requires to so we but that's especially in a year like this with low cash prices, the moisture is also very, very important. But that particular analysis does not, that's something that's been worked on, but it's another dimension of complexity. And to look at, I think you're just talking what the field dry down rates and how much is there. That is not taken into account in what I showed.
Madeline just had a question. Do yield maps give you better stability maps than satellite imagery?
Yeah, and I think it's the answer is not about the what they're measuring. I think the answer is resolution. And so it's resolution on yield data doesn't matter what size head you have, because you get so many points, and the number is fake, right? Like it's really just sensing the grain flow as it hits a pad and then giving you an estimation of what that yield is. We're not actually going out and physically weighing the crop as we go out there, right? So if we kind of take that with a grain of salt, that we're getting a relative number that we trust, but the idea is that we're getting a number, and that number is changing based on the variation of that crop at a high frequency. Now we get a lot of numbers in a field. And when we do spatial statistics, which is why I'm reiterating that this process happens in a research lab, we can get a really, really highly accurate, highly resolute map with each pixel, each spot that we have a different value for is like 10 feet by 10 feet. So then we compare that to what the satellite's seeing. Now, even though planet imagery is really high resolution with really good cameras, it's not 10 feet by 10 feet. It's something like 30 feet by 30 feet. So just the idea that the variation that we see from those two resolutions makes the yield data the gold standard the best, because we have figured out a way to find those same spatial patterns that the yield data gives us from the satellites by using high resolution satellite imagery. That we composite from multiple years.
Awesome. We'll use this time to ask our specialists if they have any updates, or our educators as well.
Nothing from me.
Thanks, Chris.
I can just make a comment about forage planting, which is with the cool weather and dryness and our normal recommendations, we are still in a situation where you could plant perennial grasses and annual grasses, but we are out of the alfalfa planting window, which ended on Labor Day. So but if it doesn't rain, it's very high risk for planting any of those things. I planted some on my farm about 2 weeks ago, and it's still sitting in the ground waiting to germinate. So maybe yesterday's rain will get it going.
Mm,
But just keep that in mind if you're planning any planting.
yeah. Thanks, Kim. Someone asked, is the field corn reducing the worms, or is the year producing fewer worms?
What was the question?
So the question was, we raise sweet corn. This year we have seen almost no worms in ears. We have farms around us with field corn. Is the field corn reducing the worms, or is the year re producing fewer worms?
So it's probably corn earworm, and corn earworm comes from the south. So I have a plot I had a plot in Frankenmuth with zero, big fat zero, and I had a plot in Swimwreck and near Benton Harbor, and it was 100% infested. So it all depends on timing of flight, and then when they got to your area, what stage that sweet corn was in. So it's more of a stage and flight related, not necessarily year to year. So there are fields that are loaded this year with earworm, and we have fall armyworm came in probably 3 weeks ago. So we have both.
Awesome. Thanks, Chris.
Leon's just lucky. So
Awesome. I guess that's all we have for today. Thank you all again for joining us for our virtual breakfast, and we'll see you next week. Have a great day.